Hi, I'm James Wedding, Senior Technical Specialist with Autodesk. Over the last few videos, you've seen us working through the design and review process for the Apple Springs development in Missouri. This time, I'm going to use the design to date and the drainage tools inside of InfraWorks 360 to put in a preliminary gravity storm system and then analyze the macro-scale hydrology for our site and an adjoining road. I'll also show you one of my favorite tricks for expanding an InfraWorks model using Model Builder and Civil 3D. I'll start with some basic storm components. Simply select any design road, right-click, and select Add Pavement Drainage. Note that I said design road. For right now, pavement drainage only works on design roads, and it really only works from back of curb to back of curb. In other words, it won't work on the roads brought in by Model Builder or your own GIS data unless you select them first, right-click, and then convert to design road. Then you can add pavement drainage. When you run the command, a card will open up offering options for sizing and offset to the main trunk line. I like to verify my settings just to make sure they match what I really want to do, and in my area we typically use 4-foot manholes, so I make that change. Press enter on the keyboard and give it a few seconds. One thing you'll find is that you'll often get the model control back. You'll be able to pan and zoom before InfraWorks is actually done displaying and calculating the inlets and manholes. It will catch up, don't freak out. With this system in place, I can select an inlet to view its properties such as spread or efficiency. And when I take this model into Civil 3D, this will all come over as a Civil 3D pipe network, ready for final tweaks or analysis. If you need to make a change to the road, realignment or some such, or want to change sizing, simply select the road and right-click again to run the Delete Pavement Drainage command. Now, this isn't the final design by any means, but it's a good start, and it gets our network and inlets generally placed in the right spots. We've run tests internally that show drainage placement with InfraWorks 360 can be done in under 5 minutes, including the transfer into Civil 3D, while placing and rotating the inlets and pipes, etc., all by itself in Civil 3D can take over 20 minutes. It's a little thing, but it really impacts your day. With a basic storm system in place, I now need to do some large-scale hydrology on the site, calculating pre-developed runoff headed out to the north in the draw that we're modifying. Now, I open the drainage tools and select the Calculate Watershed tool, and select an approximate point at the channel egress. InfraWorks 360 loads data into the cloud and returns a drainage area based on the surface I have in my model, except I don't trust it. Take a look at the edge of this drainage area. They're right along the edge of my model. I'm suspicious anytime something works that perfectly, and I really want to run this with more area. So how do I add more surface area into an existing InfraWorks 360 model? Well, you use Model Builder, of course. When John created this model originally, he selected a pretty tight area around our site. In my new Model Builder run, I select nearly the full 200 square kilometers and generate an entirely new model. With this model, I can run the same watershed analysis, and I find that the contributing area is indeed much larger than I first thought, and that I was smart to double check. Now, how do I get this terrain into the model I'm sharing with the rest of the team? I use Civil 3D. I simply insert the larger InfraWorks 360 model into Civil 3D with just the USGS-derived surface data. Now, selecting the existing ground surface, I can either drag and drop that drawing into the InfraWorks model, or I can export to Land XML. Some habits die hard here, so you can see I went ahead and put it in XML just for record purposes. Import that into the original InfraWorks 360 model that John prepared, and I have an expanded surface to work with. Now, you will have to go to the model properties in the settings area to adjust the limits of your model, but that's a pretty easy adjustment. With that expanded surface in place, I can run my watershed analysis again, and now I'm happy with the results. Now I can assign runoff coefficients if I want to use the rational method, but since we're really close to a square mile for this area, I should look at regression methods to more accurately predict runoff. There are regression equations in InfraWorks 360 for each state, or you can always simply enter your own values for runoff if you use another methodology. Now, on the southeast corner of our site, we're also dealing with a road crossing, and we've been asked to examine the creek crossing for maybe putting in a culvert. Now, InfraWorks originally put in a design bridge here because the road crossed over my creek. It was trying to help me out, but I want to get rid of it. I simply select the bridge and delete it using my keyboard. To calculate and work with a culvert design, I need to run the Watershed tool again, but this time, instead of selecting a point, I select that road. And then I specify the portion of the road that I want to analyze using the little rollers. With the watershed calculated, now I can adjust runoff methods again to come up with a flow going under the road at that point. Right-click on the road and select Add Culvert to place a culvert. And then adjust the view, and you can select the culvert to display that properties card again. With the properties card in place, I can begin either using the gizmos or the card itself to tweak the design. I can change the number of barrels, the entrance type, the wing walls. I can use circular or box configurations. As you adjust, the analysis will update, and you'll see the impact displayed in an exaggerated view of the culvert sitting sort of up in space over the road. Now, I keep adjusting this design until I get an entrance control, but I'm not running full covered pipe design. I don't want the water over the top lip of my boxes. At this point, I'm ready to call it a day, call it a preliminary design, and we're done. Thanks for watching. Next time, we're going to take this model further into detailed design and look at more of the Insert InfraWorks options inside of Civil 3D. See you then.